Hi everyone, welcome back to Newegg TV. My name is Paul, and today we have a special guest. This is Bill, the server guy. And Bill, thank you for stopping by today.
I appreciate it, thanks.
Bill is the Xeon channel manager for Intel, and what we're going to be doing today is doing a small business server build. So this is going to be geared towards people who maybe have a small business, who are looking into actually getting a server for their small business. A lot of you might be first-time users in this respect, and a lot of you might already have experience building, say, a desktop PC for gaming. So there are some nuances, some differences between servers and desktops that we're going to talk about, and we're also going to be assembling this hardware that you see right here in front of us. So Bill, why don't we take it away, and let's start off by answering some of those questions that are out there. So what would you say the biggest differences between a desktop and a server build?
The average person who's building a desktop system, when you look at priorities, cost, performance, reliability, usually it's performance that's at the top of their list. Reliability falls somewhere in the mix with cost. When you're looking at a server, one of the characteristics of a server that we actually care about is the fact that more often than not we've got a piece or a large portion of a business operation running on one of these machines. So we have a different priority. Performance falls down a little bit lower in the priority list, but reliability becomes critical. If, for example, I'll use my friend, he's got an auto repair shop. He's got two client systems at the front for customer interaction. He's got two systems in the back for the maintenance guys, and he's got a server in the middle that handles bookkeeping and does some client emails and all the customer records. Half of his business is the fixing of the cars, and the rest of the business runs on that server. So the last thing that he wants is to have that go down. His business basically stops. So reliability becomes a critical issue. The second thing is that, well, when you're working with your desktop, you're right there. The system's there. If a fan starts to go funky on us, you'll hear it. In your interaction with the system, you'll feel a change in the response of the system if something's not right. With the server, this thing's sitting in a back closet somewhere. We don't hear it, we don't see it, and as a matter of fact, the people who are interacting with it aren't interacting with it directly. They're on a client machine. So if something goes bad, something goes wrong, you might not find out about it for a while unless you have some way to manage and alert you of something that goes wrong. So we have a new criteria that we now care about. We care a lot about reliability, but now we care about manageability too. So there's a couple of the things that you'll want to think about with a server.
So as compared to a desktop, you might be looking at, well, let me get the fastest components possible. With a server, you want to gear a bit more towards long-term reliability, making sure you get parts that work. I know servers use different type of memory to make sure that there are no errors that are generated. A lot of popularity, of course, with RAID arrays, different storage techniques. And then, as you mentioned, another aspect a lot of people don't think about is the ability to be able to remotely connect to the server, determine diagnostics, and actually one other thing we should mention, just as we're doing our introduction here, is that Microsoft will be stopping by in a little while, so we are going to be installing on this server, once it is built, Windows Small Business Server 2011, and we're going to be showing some demonstration of that software as well, and then we're going to finish off with some Q&A.
Great.
That being said, are you ready to start building?
Anytime you are.
All right.
So the system that you folks selected to work with today is a great example of what we do here at Intel. Now this is a complete system built by Intel. So when we open the panel, which I guess we can start right now, you'll quickly see that most of the stuff that you find in a system is already in there and wired up. So if you're used to building say a desktop computer, the first thing that I think about when I've built these things in the past is, shoot, I'm going to have to, which do I do first? Do I want to get the power supply in or the motherboard in? And then you have to figure out the pinouts of all the front panel connectors. That's all done for you. Really all that's left is memory, processor, and hard drives. So that's one of the nice things about the system. If you don't mind, let's flip it around to the back, and I'll show you a few other nice features. There's a grill across the fan in the back here, and a lot of people might ask, what's that for? We do complete testing of these systems. So as opposed to some of our competitors, you might buy a chassis, put a motherboard in it. If you actually wanted to resell that and have it certified, FCC certified, you might have a tough time doing that. These systems, if you use our tested hardware list for the memory and hard drives, they're FCC certifiable. We know that we have margin on FCC limits. So that's one thing. The system's UL certified. It's shock and vibration tested. It's a complete package. It's ready to go. Why don't we flip around to the front? We can show one or two other things, and then we can put some hardware into the system. So up on the front panel, we have some features that are a little bit different than most front panels. This knockout here, for example, it's something different that you might not normally see on a computer. That'll accept either a DB9 or a DB15. The DB9 serial port, that sort of throws back to the days when folks were using Unix, Linux, and they used a serial connector for the console interface. More than likely, though, if you can imagine 4 or 5 of these sitting on a rack, and you want to come in and do some operations on one of the systems, none of these systems need to have a KVM or keyboard, video, and mouse attached. So if you put a video, you can pipe a video signal up into this connector up front. You've got 2 USB ports and a video signal. You can literally come in with a cart, and all your connections are right on the front of the system. You don't have to go around to the back.
Very handy.
Manageability here. There's a button / indicator light right here on the front, and it says ID next to it. And it's really that simple. It sounds almost dumb, but it's an ID light. If you're remotely managing these systems and you find a fault on one of the systems, well, you're going to have to identify which one it is.
Especially if you have a lot of them all in a row.
Exactly.
Yeah.
So that ID light is exactly that. On the management console, you click a button and that ID light lights up. Or vice versa, if you're out there and you find something wrong and you need to tell the management folks about it, you can press the button and it alerts them.
Oh, okay.
Then you've got a handful of indicators, which are typical, hard drive activity indicators, and a power indicator, or I'm sorry, a power button and a reset button. So those things are fairly typical. I think the rest of the stuff we can talk about as we go along. One last note about this, and I think it'll become apparent once Microsoft starts what they do. We put a lot of effort into the acoustic design of the system. You'll notice there's only one fan. Well, actually there is a fan in the power supply, but there's only one other fan in the system. And it's a little bit thicker than most fans that you'll see. This thing, once the management controller is flashed and it's booted up and ready to go, this runs at about 27 dB, which with the noise in here in this room, you shouldn't be able to hear it very much. It's a very quiet system compared to most servers. So if you're going to build one of these systems, I know most folks don't like to use manuals, you might notice that there is no thick manual that came out of the box here. The only thing we give you is pretty easy to follow. Usually these things are big fold-out sheets, but they've done this a little bit better. It's a step-by-step process of what you need to do, and it's really painfully simple. So my suggestion is let's see what this tells us to do and follow it along.
Okay.
Install the board. It's already there. All right, remove the bezel assembly. And I'll let you do that. There's just 2 tabs there on the front, and it swings out of the way.
Front bezel.
Yep, and now you get to do the front bezel juggle that most chassis manufacturers have you do.
Ah, I see. Ta-da.
Okay, so the drives are next. And I'll hand you an optical drive to start with.
Okay.
Now, before you go anywhere, we can pull 2 of these off, and you can actually plop those on the side of the drive. No screws involved.
Hey, very nice. Easy to attach. I know of some desktop cases that could benefit from this design.
And slide it on in.
Okay. Oh, we do have a front panel.
Or if we actually want to run a cable on it first, I don't know which way you prefer to do it.
We can connect the cable after it's in there, I think.
Good.
Locked in.
Step 1, good. Now let's talk about hard drives. The hard drive trays, let's spin the chassis around here so we can see the front. Once again, we have a grill here for EMI purposes. And we'll need to remove the grill, which should be a simple operation of, oh gosh, just pulling it up like that. Okay, it was really easy.
That was pretty easy.
Now, the hard drive trays come out literally that easily.
Okay.
And you can mount the drives a couple of different ways. Usually we use the 4 drive or screw locations on the bottom of the drive. But we've got 2 drives here since we're going to do a RAID array. So let's take a minute and put some drives in.
Screws for drive mounting are attached to the trays themselves.
Okay, so we have 2 hard drives mounted on trays.
There we go.
These should be pretty easy to put back in. And once again, I'll let you do the honors.
Should just slide onto the rack right here. And locked in. Well, it will be locked in once we put that front cover back on.
Okay, following the instructions, we have a card guide for the PCI cards.
So this is just a bracket that holds PCI cards in place.
Exactly.
Especially, I imagine, for transporting, that's very helpful.
Yeah, and as I talked about before, with our philosophy of designing a full system, we do shock and vibe, both with the bare chassis with cards installed and packaged shock and vibe. The idea being if you wanted to, if you were going to resell one of these systems, for example, you populated the system, you can put it back in our packaging and ship it, and you can be confident that it's not going to break in the process.
All right. This particular bracket just slots in right here. There's a couple notches on this side that will allow it to pop into place. Of course, there are some case cables here as well. Should watch out for. And then once it's in, there are 2 mounting points there. Just a couple screws to hold that in place. And we're all set.
Okay, moving right along. PCI card assembly. We're not using any PCI cards today, but there's another opportunity to talk about one of the nice things about this system. We are going to install a RAID card. Now, for an entry system with 2 drives, what we're about to install might be a little bit overkill, but it's a good example of some of the features of the product, number 1. But number 2, what's possible for maybe a higher end application. So this system comes with, wow, it's wired up already, good. 2 6 gigabit SATA ports and 4 3 gigabit SATA ports.
Down there at the bottom?
Yes. Now, for a system like this with 2 hard drives, no problem. We're going to use a RAID mirror. We could do it without this RAID card. But if we had more drives, and more high-performance drives, this card would actually come in handy. This is and I assume we'll show it here, this is an 8-port RAID card. There is a 4-port version of this. And as opposed to what you would expect with a PCI RAID card, this is a PCI RAID card, except it's got a proprietary or a special mezzanine connector. So you can install this in the system, and you don't have to worry about taking up PCI slots. So if you had the need for all those slots, and some customers do, this doesn't take one. So to put this in, we'll use, we're going to probably have to pop off a couple, well, you don't have to, but you should pop off a couple of those SATA cables. And we have a couple of standoffs here.
This plug right down here at the bottom?
Yes, that's it. And here are 4 standoffs. So I guess we should put the standoffs on the card first.
Okay. There we go.
Now, let's think ahead a little bit, and let's put our SATA connectors on this before you stick it in.
Okay.
You can pop them out of the 2 top ports, the 6 gigabit ports are probably the best place to pull them out of.
Okay.
Now, ports 1 through 4 are on this edge of the board, and port 0 is there, so port 0 through 3 actually is on the edge of the board.
Okay. Ooh. Always make sure your SATA cables are oriented correctly. Now this should be able to drop in. Ta-da! RAID card.
Okay, and I guess the next logical progression is to start connecting up our drives.
Okay. Of course, cable management in a server just as important as in a desktop.
And to that end, one of the things that you'll find in the kit full of parts is a number of cable management tools, should you need more than what we've already provided in the system.
All right, so our SATA drives are wired up for data at least.
And we got an optical drive we need to hook up, I guess.
Okay. There we go.
Beautiful. Now they tell us to put the front bezel back on.
Okay.
So this will be a two-step process. You get to take the filler panel out from the front bezel, and I'll put the shield back on.
Okay.
Once again, here. Come on, you can do it. Get this upside down. All right.
So this also performs the purpose of holding those hard drive racks in place.
Yes, it does. Now you'll probably want to pop the cosmetic bezel out for the optical drive.
Oh yes,
There you go.
you're right. I should know this. Believe it or not, this is something you also do with a desktop build. That just snaps right around the side. So those latches are in. It closes.
All right.
Front bezel is back on.
Now it's time to, I guess, set it on its side. Processor and memory. So one of the things that that I'd like to explain, we haven't talked about the Xeon family of processors yet in the discussion. When we talk about reliability features, we're about to start talking about error correcting memory. We'll get to that in a second. But one of the first things you want to start with is a Xeon processor. Xeon, as opposed to the Core family of processors at Intel, Core i3, i5, i7, those parts don't support ECC memory or error correcting code memory. The Xeon parts do. Now, when it comes to buying a Xeon part, the single socket Xeons, which is what we're using here today, this is the entry-level platform, they come with the heatsink included, just like the desktop parts do. If your customers graduate to the point where they're going to be using the dual socket parts, those heatsinks are sold separately. Give you a little bit more flexibility if you're using a rack chassis versus a pedestal and the different sizes of heatsinks. So, with that said, let's let you do the honors.
Move on to our CPU installation. So anyone who has installed a desktop CPU, this is identical. We have the same LGA socket, 2 notches at the side, which indicate the appropriate orientation of the CPU in the socket. Of course, there's a removable plastic cover on the socket itself. Once that's exposed, be really careful not to touch any of those exposed pins, and the CPU drops in straight down without putting pressure on one side or the other disproportionately, because those pins are very delicate. And we just have a pressure plate here that slips back under that little notch. The arm closes. It will take a little bit of pressure to put that arm back in place. And now the CPU is securely locked in the socket.
Heatsink.
And now we have the heatsink. Again, pretty much identical to a desktop system. This is a stock heatsink, so it has thermal paste that is pre-applied to the bottom in some very nice looking strips. We just want to make sure that the CPU 4-pin connector is somewhat close to the CPU fan header on the motherboard itself, which is right there. So I'm going to position this like this, with the 4 push pins lined up. The CPU will drop down, and we want to use opposite corners to push down and lock that in place. And it is secure. Of course, we must plug in our CPU fan header. And now we've got a CPU and a heatsink fan.
Good deal. Okay, memory. Now, the little discussion about this product. The single socket Xeon parts, what we call the E3 family, has 2 memory channels. So you'll see on the motherboard that you've got 2 color-coded sets of color-coded connectors, black and blue. So you'll be populating these in pairs, and luckily enough, we've got 4 DIMMs here. So you can do the honors.
So we're going with all 4 DIMMs, and generally speaking for dual channel memory, and again this is just from my desktop experience, but it will usually indicate in the motherboard manual which sockets to populate first. Again, since we're using all 4, we don't really have to worry about that. We're going to have dual channel in both sets of sockets. Memory installation, again, pretty much identical to your desktop build. You just got to align the memory in the socket. Of course, there's one notch there that's off center, so make sure that that is lined up with the notch in the DIMM slot. You line it up there, firm pressure on both sides of the memory at once. The clips will lock into place, and then your memory is installed. Just got a couple more modules here to pop in. And there we go.
Well, it's about time to start hooking up the power.
All right. Again, our Intel chassis here has the power supply, and all our cables are bundled up here nicely. We'll just need to undo that. Power's already connected, so really we just need 3 serial ATA connectors, one for our optical drive and one for each of our hard drives. All right, hard drives have power. One more for the optical drive. All right, and our peripherals are connected.
So it looks like it's time to do the honors with a couple of stickers and to button it up.
Stickers.
Yeah.
Stickers are my favorite part. So this is just a sticker that's included, which you can apply to the side panel of the case, and that will just give you a layout of the motherboard. So any future maintenance that needs to be done, or anyone who needs to jump into the case to make sure everything is connected appropriately or add new hardware, we'll have a layout of the entire system right there. Oh, I got a bubble. That should be fine.
Now, also included, we have stickers for the I/O panel.
Okay.
These are much smaller and much more intricate to put on, so we might want to just take a minute and do these offline.
All right.
Okay, with the labels now on the back, there's a couple of things I'd like to point out to you. First, there's a little tiny label here with a handful of little openings in the back. I'm sure that you've got in your lab here somewhere a postcard.
Yes.
These are diagnostic LEDs, very similar to a postcard. So while there are beep codes associated with some diagnostics on this, there's a whole another level of diagnostics that are available right with these LEDs on the back. You'll notice 2 NIC ports, again, for server operations. If you're doing virtualization, for example, in other words, having multiple applications running on the same server in different operating system partitions, having multiple NIC ports, that's just one application, but having multiple NIC ports is handy. You can assign 1 NIC port per server, for example, per virtual server.
Okay.
There's other applications. You can team them together for better bandwidth and so forth. What else can we talk about? The one thing that we haven't talked about, and it really doesn't show up on the server itself, is the management capabilities. On the motherboard is what we call a baseboard management controller, or BMC. It's basically a small processor, and it's connected to a number of sensors. That processor monitors temperatures, voltages, fan speeds. There's a chassis intrusion switch on the system that it can monitor, among other things. And there's software that we include with the system, management software, that basically you can put in a client system somewhere and program it to monitor the server.
Okay.
So when we were talking about the idea of being able to tell if the server fails, even though we rarely see it, it might be in a closet somewhere, we can program this to send us alerts, maybe a text message or an email that a fan has failed or maybe a drive in the RAID array has failed. Those are some of the capabilities that are built into the system. You can actually upgrade this with 2 different management controllers, and you can get the capability to do what we call out-of-band management. So with an upgrade to the management controller, you can get KVM over IP or keyboard video mouse capability over an IP connection. So this can be sitting here on the West Coast. I can be at my family's house on the East Coast, and if I have an IP connection at my brother's house, I can manage the server. And it was as if the server was sitting next to me. If I wanted to load an operating system, I can literally map my CD-ROM drive remotely to the server on the other coast. And we have out-of-band capability. What's that mean? If this thing is locked up, let's say, we don't have operating system access. We can, with that upgraded management controller, get into the system and shut it down, restart it. We can get into the BIOS setup screens, the RAID setup screens. We can do all these things that are nice to be able to do to the system, but with other management solutions, you have to have an operating system running. With this one, you don't have to have an operating system running. It will run out of band.
So even remotely, you can still get access to all those low-level BIOS settings.
Exactly.
So you can really do a lot of maintenance and not have to be physically right there with the server.
Firmware updates, for example, changes in hardware configuration, although I can't imagine why you would want to do that remotely, but it's all possible.
Somebody else just installed the new hardware and they want you to come in and configure it.
It's a possible scenario.